Welcome to InnoBuzz Java video tutorial part 10. In this chapter, we are going to talk about threads. First, we have to define what it means, thread. Why are we using threads? What can we do with threads? And how can we control them? Let's see the overview of this chapter. We will see the definition of the thread. We will talk about the advantages of using threads. We will follow the life cycle of the thread. We will talk about how the operational system handles threads. We will see how the Java virtual machine handles threads. And we will implement threads in Java. What is a thread? The definition is the following. Thread is a programming tool that allows handling concurrent processes. First, we have to talk about processes and threads. The operation system runs application, and all applications have their own processes and threads for parallelizing execution. But there are some differences between process and thread. We can imagine like this. Threads exist subsets of processes while a process is independent. The process has own state information, uses own address space out of reach in the memory, while threads don't have that state information like processes. Uses shared memory with other threads. It is important that processes communicate each other via inter-process communication mechanism, managed by processor, while threads communicate with the shared memory. Context switching between threads in the same process is typically faster than context switching between processes. We are continuing talking about threads because when we are developing an application, we can only control them. And all threads has name. The program will identify threads by name. What is the advantage of using threads? When we launch a program, the Java virtual machine starts a thread. It is usually the main method. And we can directly start other threads from main thread. The main advantage of using threads is that we can make our program faster by sorting tasks in threads and execute them at the same time. This is the multi-threading. But we can also use threads when we want to stop our application for a while. For example, let the user read the page before the program moves on, or wait for synchronization. The two basic ways of using threads, as I've told, is the sequential way, when the tasks follow each other in one flow, and the multi-threaded, when the tasks run parallelly. This chapter mostly covers information on the one-threaded way. Let's see the life cycle of a thread. The thread can have 6 states. Let's see them. When we create it, when we start a thread, it's new. It is created, it is a new object. As in the Java language, everything is an object. But we didn't start it yet. We didn't call the start method. When the thread runs, the state can be runnable. We started the thread, and the JVM is executing it. It's not sure that our thread starts immediately, because the thread is waiting for a turn on the processor. It can be blocked, the thread stopped by the Java virtual machine. It can be waiting, the thread is waiting for another thread. And it can be time waiting, the thread is waiting for the specified time, user specified time. And at the end, when the thread finishes the life cycle, it becomes terminated. The thread has finished his task. These constants we can find in the thread.state enum. Let us see now how we can control the states of threads. What are the methods for it? There is a sleep. We can send our thread to bed for a given time, in milliseconds or nanos. Sleep method has to be surrounded by a try-catch block. The thread state is time waiting for this period. Wait. We can stop our thread like sleep, but it is also useful at the synchronization of threads, multiple threads. We are going to see in the next chapter. The stop, we can terminate the thread. Actually, this is a deprecated function in Java, so it is not recommended to use it anymore because we can lose data by using with it. It is more suggested to use the wait until the end of run method. The yield, if we have a thread that uses the CPU many times for long periods, we can directly stop using CPU with this thread and let other threads to be working. Is alive. This method returns true if the thread is runnable. That means if we have already started and didn't finish yet. If the thread is new or terminated, the method returns false. The getState method returns the state of the thread that we were talking about in the previous slide. How does the operational system handle threads? If you write a program, for example in Java language, or if there is a program running under our operational system that has multitasking, or there are multiple threads, so more than one programs running at the same time, there are basically two ways to handle this situation. The operational system can use the time division multiplexing, TDM. This way, a single processor switches between different threads frequently enough that the user perceives that the tasks run at the same time. All threads have a priority, and an algorithm chooses between them depending on that priority. So it is switching between threads. On a multiprocessor computer, the threads actually run parallelly at the same time. So this means that all threads have its own processor that executes the process. In modern operating systems, both ways are supported. Now let's see how the JVM handles the threads. When we are writing programs in Java, we can set the priority of our threads. The thread which has a higher priority will run sooner. This can be between 1 and 10. There are three final variables in the thread class to help us setting priority. The max priority is 10. The min priority is 1, and the norm priority is 5. A new thread starts with the same priority as the creating thread. So this is the default. We can also use daemon threads. We can mark our threads as a daemon. Daemon threads are used for servicing other threads. Typically, contains an infinite loop and does its task when it gets a service request. The GVM is running while there is one non-daemon thread at least, so the main thread cannot be daemon. Let us now see the ways of implementing threads in Java language. There are basically two ways. The first is when we extend the thread class. The second is when we implement runnable interface. In the next slide, we are going to see them in details. Let us now talk about a little bit which is the better way, or what's the difference between them. In Java, a class can have only one superclass, as we have already seen. So if our thread class extends the Java long thread, it cannot inherit from any other classes. This limits how our program can reuse our application logic. The instances of classes that implement runnable interface can be passed to other libraries that accept task submission. For example, java.util concurrent.executors. A thread subclass inherits all the overhead of thread management, and it is hard to reuse. The two ways of creating threads differ also in the life cycle of the thread instances. Once a thread is started and completed its work, it's subject to garbage collection. An instance of runnable task can be resubmitted or retired multiple times. Though usually new tasks are instantiated for each submission to ease state management. And there is still one big difference between implementing the runnable and extending thread, is that by extending thread, each of your threads will have a unique object associated with it. But when we implement runnable, many threads can share the same object instance. And we shouldn't forget that a class that implements runnable is not a thread. It is still just a class. If you want to create a thread from a runnable, we have to create an instance of thread and pass the runnable as a target. In most of the cases, the runnable interface should be used if we are only planning to override the run method and no other thread methods. This is important because classes should not be subclassed unless the programmer intends on modifying or enhancing the fundamental behavior of the class. The first way of creating threads is extending thread class. This is very simple. We write public class, my thread, for example, and the extends keyword and thread. We can override the run method and write other program parts as well. And this way, we have already extended thread class. And we can make a new object instance of this subclass, and we can start a thread by calling the start method of it. Let's see what constructors we inherit from thread class. The empty parameter thread is without naming the thread. The GVM will name it. If we use a string parameter, then we give the name of the thread. The third constructor is when we give a runnable, and this time also the GVM names it, and we give the target runnable. So the void run that will be executed when we use this thread will belong to this target runnable. And also we can use this with a name as well. This is the easiest way to create threads. We will see it in practice. And it is not much more complicated to implement the runnable interface at the first sight. Public class myThread implements runnable. This means that we have to implement the run method and write some program code in it, of course. But the run method cannot have any arguments because this is the signature in the runnable interface. Write the other program parts that we want, and that's it. In this class, we need to declare a variable with a type of thread for using thread methods, but our class can still extend other classes. Here we are again to make some practice on the threads. Now, I start with an empty project, and I didn't put anything in yet. And I'm going to create some new classes which contain threads. Let's add a new class. I'm gonna call it myThread. We have it here. Okay. And myThread extends thread. Okay. Now what we are going to put in there is a constructor, just simply public myThread with a string name. Thread name, and we are going to call the super constructor with the name. And this is already a constructor. And I'm going to override the public void run. And what I will put in there is the simple for cycle. Which goes until 5, maybe. I++. And what we will have inside is a simple system out. Just we will write like well, get name. I want to see the name. Yeah, the name of the thread always, because we will have more than one threads. And this I, that's it. And just put a sleep here. And As I've told, the sleep should be in a try-catch block. Just 10 milliseconds. Of course, I write a catch here. Well, it's we can catch interrupted exceptions here. I hope I have written it right. And just write interrupted or something. No matter. Oh, I forgot this N. Okay. Now, just to see what is this doing. After the fourth cycle, we also write out that it is finished. 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 That's it. Okay. And of course, I also write the name. So we will see which thread is going to finish. Now this is a simple code for the thread. And we are going to save it, and I'm going to make another one which is similar to this one. I call it my thread 2. And in fact, I will put everything there. Just the same. I'm going to change a few things. My thread 2. My thread 2. So it's the same thing. What I will change, that I don't use the sleep here. I will use something else. This time I use the yield. As I've mentioned, the yield lets the other threads to use the processor. So if we use the yield, then it will wait for the other threads. Okay, now we have two thread classes here. The one is sleeping, 10 milliseconds, the other is making yield. What I'm going to do is write a daemon class for them, so which is going to be the head of them. So we will see how the daemon works with these threads. This is also a thread, so it also extends thread. And I'm going to create threads, instantiate them. New my thread. Let's call it like A or something. The same thing with the other, which is going to be a B. course, I use a different name. Okay. And write a constructor. My daemon. Thread name. Okay. So I'm going to do something very simple. Just call the super and with the name, and then I'm going to start these threads. So I'm going to say thread dot start. I'm going to start the thread, and also I'm going to start thread 2. Now that's it. What I will do, of course, is write the public void run now with empty argument list. And as I have mentioned, the daemon threads usually use infinite loops, just while true. So we will use something to from outside to stop this cycle. What we do now is write the try-catch block inside for a sleep. Just 10 milliseconds, for example, and I catch, well, I copy, I will catch same exception. This is frequently used for threads, the interrupted exception. This is a very frequent exception type, and well, this is the best to write out the print stack trace here instead of this. Yeah, print stack trace. Okay, now that's about the try catch, and I say if thread is alive, so we will check the status of the thread, of the first thread here. We will do the following things. I'm going to write out that this thread is alive, that thread dot get name is alive, and if it is alive, I'm going to also check, for example, if it is if it has the state waiting, because as I set it waiting, so I can use the get state here to check the state of it, and I use this yes, I say timed waiting because we, as I've mentioned, these are the block, the new, runnable, terminated, waiting, and the timed waiting when the user defines a time for the waiting. And if the thread is sleeping for a timed amount of time, we'll just write out something like sleeping something. And what I still want to do is say when the thread is not alive. What are we going to do then? Well, then this means that the first thread is dead. So this time we are going to say that thread is dead. Okay, thread is dead. And I'm also going to check here that this is a new if, that if the second thread is alive, thread 2 is alive, then I write out that the same thing. The name is alive. So we are going to check both of them. And of course, the same thing for the second. I change the names of the threads and that's it. So I just simply check both of them if they are dead or alive. Yeah. Wanted dead or alive. This is for the threads now. And to be able to try this out, I only have to write a very short main method, like I create a thread, which is the daemon. Here, I instantiate it with my daemon, with a name, of course, daemon, and I say that it daemon dot set daemon. You can see the set methods for it. The set daemon, which I use to create to make it a daemon true, and that's it. From now on, this is a daemon thread, and what I have to do is still just to start it. Start. That's it. So I created a thread just to watch it over what it does. I created a thread here, which is going to be an instance of this my daemon, which stands thread. So as you can see here, there is nothing about that it is a daemon thread or something. This scopes with other threads, as you can see here. But when I create it, I set it a daemon. And that's how this can cope with the threads. I create 2 threads and check if they are alive or dead. One of them uses sleep, the other uses a yield. Let's see now how it works. I run it. Okay. Well, it starts with a B. First, the B is going to run because we started the 2 things. The first is the A, the second is the B. We started the B because the A was sleeping, and then we got one A here. Then we continue on with the B because the A is sleeping, and while the A is sleeping here, it can do all the B's, so the B can run while the A is sleeping because there is no sleep here. It's just a yield, so if there is another thread which wants to use the CPU, then it gives the possibility, the yield, but because the other is sleeping, it can simply work and finish, as we can see here. But then the daemon checks after 10 milliseconds that what is happening, and A is alive because it is still working, but it is sleeping, as we can see. Well, I forgot to write the name, but it's about A as well. A is sleeping. B is dead because B has already finished working. But then, after a few milliseconds, the A is working again, and it produces the 2 and the 3, and then when the next time we check it here, we see that A is alive, but it is sleeping again, and B is dead just like before, and then A is alive and it is sleeping. We get 2 checks here, one after the other. Then A gives us the 4, and the A finishes, and then both of them is dead, as we can see. This is what is happening. Well, what I can do to this is because it's a little bit sometimes hard to see what is happening because they use the same amount of sleep, so it is better to use less here just to try it out. Yeah, we start with B. Now the B runs, and A runs one time only, and B is already finished. Then A is working. Sometimes it checks. It's always the same thing. And A is working in these periods, and the same thing happens. So now we get less checkings and more working because the thread sleeps less than the daemon, the checking. But we couldn't really see that the yield, what the yield is doing. So we cannot see because it is always sleeping the first thread. I'm gonna comment this out to see that if none of them has a sleep and the code is only different with this yield, then we will see that if I run it, Yeah, it starts with the A and the first thread, and it goes through all it can finish. So it can finish the whole working, and the B is just waiting for the A to finish, and B works after it. This is because they yield. They start, both of them start at the beginning, but then the B is not working because the A is working, and it gives the possibility to it. So this is how the yield works, for example. This whole example was only about creating threads and daemon threads, and see a little bit how they work. I'm going to show more in the next practice, and we are going to see also a lot more in the next chapter in the multiple threads. I still want to show something in practice about the threads. We have talked about this in the slides, that the difference between the implementing the runnable and the extending thread. And this is a very interesting point. To be able to show this, I'm going to create also some classes here. One of them is going to be extending thread, and the other is implementing runnable. Well, let's see. I call implementer. I call it implementer just to see that this is going to implement the runnable. So we have a class that is called implementer, and it implements runnable. Runnable. Okay. Now what we want to do is use a counter here. Let's make it private. Counter, and of course I have to implement the public void run. Here, and what I will write here is also a for cycle like int equals 0, e is smaller than 5, e plus plus. That's it, and just write out something just like before. Just get name, and yes, of course, I cannot just simply use the get name here, because when I'm implementing, I have to use it like this thread, and get the current thread, because as I've told that this class will be used by more threads, more than one. So this is the point that I'm going to show a little bit later. So the name, okay, and well, I just use the counter. Okay, so I increment the counter, that's it. And make a sleep here, something like maybe 500. Okay, and that's it. I catch, and well, I have to put this whole thing in a because I use sleep, so I have to use a try catch block, of course. Sorry, and catch. Well, interrupted exception. Okay, and I just print track traces the best here. Okay, that's it. Yeah, and of course, and as I've said, I still have to use the thread here. So we are going to make the thread sleep this way. We will see that the reason for that. I just save it. Okay. The other is going to be an extender. I'm going to call it extender. Which stands thread. As we have already done this. There's also a counter here. Well, I just copy, and what I want to do is make a constructor for it, public extender with a name, just quickly, super name, that's it. This is an extender, of course. And of course I use the run just like here. Something like here. Yes, this is also good here. So they are doing the same thing. Um, this is how this is going to be able to work. And what I'm going to do is create an implementer. The implementer here, which is going to be, of course, the instance of the implementer, which is implementing the runable, And yeah, I don't use a new constructor here, so it's an implementer. And I'm going to create some threads here. Thread, like T thread, yeah, thread 1 and thing like that. And this is going to be a new thread. So I'm instantiating thread with a normal constructor, but as I've already mentioned, when I want to use the implementer class, I have to pass it as a parameter. So I create it like this. I pass this, and I pass a name, something like thread 1 or something like that. And for example, I can create another one, thread 2, with the same thing. And I also use the imp here, so the same runnable, the same class that implemented runnable, the same instance of this. And I give it another name. And I'm also creating some further threads. This is also going to be thread, but this time I use the extender. For this. And for the extender, I only need a name. So I say that thread 3, and that's it. Because the constructor of it looks like this. That's it. So the difference is that I use the same instance here, and I created different instances for that. And I just simply start all of them and see what is happening. Just like thread 1.start, and I copy it. I start the 2 and the 3 and the 4. That's it. We are going to see how this works out if I run it. Wow. So we have started with thread 2. It was 0. The 4, it was 0. The 1 became 1. Well, how did it happen? When we started with the 1, then it uses the same counter because it uses the same class. So this counter is the same for both the thread 1 and the thread 2. This is the point here. And if you watch the 4 and the 3, they both start from 0. And then the 4 is 1, and then the 3 is 1. So they are not incremented, only 1 by 1. So they are different. And the thread 4 is 2. And the thread 3 is 2 again. But this is like, if we count them, the first and the second is 0 here, the first is 1. If we see the next one is the second, it's like 2, the one is 3, The second is 4. So it's incrementing each time one of them is working. So this is the big difference between the implementing. How I create them, how I create the class. I have to implement the run, and I can use it like this, just as I've told. So I have to create instances just like this. Of course, we are going to use them in the multiple threads as well in the next chapter. So we are going to create them more, and we can see more.